Okay, so this is basically, this is the recursive formula that we learned before. So to get to any term, you take the one before it and do something to it. Add the common difference in this case. So the recursive formula kind of looks like this. And with the recursive formula, there's two things we have to do. We have to state this, and we also have to state what the first term is. Those are the two things that we had to state in the recursive formula. What the first term is, and then what the common difference is. Okay, so number 5. If you wanted to know how much Ashley saved a month after 4 years, would the recursive formula be an effective way? No, it's irritating. Because you'd have to add all the way up to that point. You'd have to write out 48 terms. So the recursive formula is somewhat limited in what you can do with it. So the next step was they were trying to help you remember the formula, the explicit formula. And they said, okay, if the first term is just A, what do we do to get to the second term? Well, we take that first term and we add a common difference. And to get to the third term, we'd add one more common difference. So D plus D makes 2D. And to get to the fourth term, we'd add one more common difference. So 2D plus D is 3D. And to get to the fifth term, we'd add one more common difference. So 3D plus D is 4D. Now I want you to look at this, which is n, the number of the term, and this. Look at this and this. Look at this and this. Look at this and this. Do you notice that the number of common differences is always one less than the number of the term? So if this is the fifth term, I do n minus 1 or 4D. That's where this formula comes from. The number of common differences is always one less than the number of the term. Now this one would be very helpful for finding the 48th term. We just plug in 48. That makes it a lot easier. So the explicit formula is to find any term in an arithmetic sequence. You take the first term and you add to that n minus 1 common differences. That is the explicit formula. All right, questions about that?
What does n stand for?
N is the number of the term. Like first term, n would be 1. Second term, n would be 2. Third term, n would be 3. Fourth term, n would be 4.
Okay.
Why wouldn't like the A change, and why does the D always change, but why does the A change? Like, you know what I'm saying? Like, is it like the same term?
It all changes. Let's go back up. So in this case, if we looked at the explicit formula, given this case, the first term is 2. The first term is 2. Does everybody see that? N, in this case, would represent the number of months, or the position in the sequence. D is our common difference. Every month, how is it changing? We were increasing by 4, so it's a positive 4. Okay? So that's what this formula would look like. So if I wanted to know how much money I'd have 36 months into it, I would just plug in 36 right here. And that would tell me the amount after 36 months. Does that make sense? Okay, so that's how this works. All right, now when we go to plot an arithmetic sequence, it ends up being linear. And it makes sense. If we look at our equation, a sub n equals a sub 1 plus n minus 1 times d, this is linear. Because we actually end up getting something for this one. In our case, it was 2. And our common difference was 4. And this is a linear equation. So our first term is 2. Our common difference is 4. And that it actually ends up being our slope. From here we go up 4 over 1. Up 4 over 1. Now on my graph, I had different counting numbers on the axis. I counted by 2s on the vertical axis. And that vertical axis represents the amount we have saved. And I counted by 1s on the horizontal axis, and that represents the number of months. Okay, so that horizontal is the months, the vertical is the amount saved. It ends up being a straight line. And the D ends up representing the slope of the line. Make sense? Okay, so for this one, this is our D. This is the slope of the line. This is our D. This is the slope of the line. Now these are the recursive formulas. So this is our first term, but this is what we're adding every time, which is our slope of the line. This is recursive. So this is what we're adding every time. This is our D. So that is the slope of the line. Now the y-intercept isn't as important to me because most of the time when we have a sequence that relates to a word problem, we don't have a zero term. Most of the time we have a first term is where we start. And a y-intercept would represent the zero term. Number 2? The slope is what we're multiplying the n minus 1 times. So the slope is just what's in front of n minus 1, because that's our d. So if we look at the formula, is a sub n equals a sub 1 plus n minus 1 times d. Well, in this one, all they did was move the d out in front. So the slope is that number that's out in front that's being multiplied times n minus 1. Now to find the y-intercept, you would have to distribute this and combine like terms. Okay, so this one is increasing by 3, so d is 3. The first term is 1. So when we plug it into the formula, 1 is our first term, d is 3. Now, it said, what are the next 5 terms? Well, the easiest, treat it like recursive. If d is 3, add 3, add 3, add 3, add 3, add 3. We do not have to use the explicit formula for that. If I just ask you for the next couple of terms, you're doing that in your head. You knew how to do that probably in 3rd grade. You could have told me what the next 3 terms would be. So, when stuff is just innate to you, don't try to pull out a crazy formula and use it. Just do what makes sense. All right, now this one. If the last term is 133, how many terms are there? So this is asking us to solve for n, the number of terms. If that last term is 133, we plug that in for a sub n and solve. Subtract 1, divide by 3, add 1, n is 45. Okay, if you didn't get that right, write that down because I'm going to ask you to do some more like that today. the next little section is interesting. Can we look at a sequence and come up with a formula for it? It's not something you're going to be tested on right now, because this formula is neither arithmetic nor geometric. It is not either. We can come up with a formula for this. It's just not one of the two you know. So if we had 2 here, and then we had 5 here, and then we had 10 here, and then we had 17 there. Do you guys remember when you studied quadratics and we looked at the first difference is 3, the first difference is 5, the first difference is 7. When you look at that second difference, that's when we get the same thing. When the second difference is constant, it's a quadratic. And do y'all see how it's represented by a quadratic? But that is neither arithmetic nor geometric. All right, now the next one is geometric. We were doubling. So instead of addition, this time we are using multiplication. Now, with repeated addition, we ended up having multiplication in our formula. With repeated multiplication, we're going to end up having powers in our formula, because repeated multiplication is represented with exponents. Okay? So, what did we do to find the next term? We doubled the one before it. So this is how it looked when we studied the recursive formula. The recursive formula looked like this. This time we have a common ratio. And the recursive formula has 2 parts. First, we have to define the first term. The first term is blah. And then we say to find any other term, you do whatever the common ratio is. If I'm doubling, the common ratio is a 2. If I'm halving, the common ratio would be 1/2. All right? This says, what if Gina wanted to know how much she saved after 4 years? Would the recursive formula be an effective way? No. The recursive formula is very nice for finding the next couple of terms. And that's about it.
So wait, what's the difference? I know that like R and the D stand for 2 different things, but like why wouldn't you use like D for this? Because like you're multiplying.
D stands for common difference. And the reason we call it a common difference is because if I do 6 minus 2, you get 4. If I do 10 minus 6, you get 4. If I do 14 minus 10, you get 4. If I did 18 minus 14, you get 4. If I do 22 minus 18, you get 4. The difference, the common difference, is 4. That's why it's called common, because it's the same, no matter which two. Now, if I did the difference here, I don't get the same thing. But if I do the ratio, I do. So if I took this number and divided it by the one before it, I get 2. If I took this number and divide by the one before it, I get 2. If I take this number and divide by the one before it, I get 2. If I take this number and divide by the one before it, I get 2. If I take this number and divide by the one before it, I get 2. So this is why we call it a ratio, because it looks like a ratio. So that's why we just use the R on this.
Is ratio usually multiplication, the difference is usually adding, subtracting, or just either or?
Yep, exactly. Okay, so let's see if we can come up with a formula for this one. This time, every time we're multiplying by a common ratio. So if whatever the first term is what it is. To get the next term, you multiply by a common ratio. To get the next term, you multiply by another common ratio. So r times r is r squared. To get to the next term, you multiply by another common ratio. So r squared times r is r cubed. And then again, gives me r to the fourth. And then again, would give me r to the fifth. Now, let's look. This has 0 r's. This one has 1 common ratio, 2 common ratio, 3 common ratio, 4 common ratio. Do you see that the number of common ratios is always 1 less than the number of the term? And that's where the formula comes from. We multiply by the number of common ratios that is 1 less than the number of the term. Now, this should look like an exponential equation because we have a variable in the exponent. And so when you went to graph it, you should have ended up with a pretty increasing exponential curve. Now, let's talk about why both of my graphs are wrong. Should I have connected the dots on either graph? No, this is discrete data. So we really should only have these points. Now the reason we did connect the dots was so you could see, does that look like an exponential function? Yes. We really should not have connected the dots on either one of them. Okay, now, these are really close to being n minus 1, but they're not, they're just n. So they're close to being in the right form. On this one, really what I care about is the common ratio. To get the first term, we would plug in 1, and it would give us the first term. So these two are not in the normal form. The normal form looks like this. G sub n equals the first term times the common ratio raised to the n minus 1. This looks more like exponential growth and decay. And because it was in terms of a word problem up here, we actually could call it growth and decay. If it wasn't in terms of a word problem, this one's just increasing, this one's decreasing. Okay, so do you guys see we're multiplying by -6 on this one? Which makes it interesting, because when we multiply by negative, our sequence alternates from positive to negative. Kind of cool. So that's a possibility. When it's a geometric sequence, it is possible that we can alternate if our common ratio is negative. All right, this one's in the right form, yay! So this is going to be our first term right here, 2. And what is my common ratio? What am I multiplying by? A fourth. So 2 times a fourth is a half, times a fourth, times a fourth, times a fourth. Now with exponentials can get really big or really small quickly. You would have to hit the math fraction enter button probably on your calculator to get it turning into a fraction. Math, fraction, enter to make it turn it into the fraction. Don't give me crazy decimals. And I'll try to not give you problems that give you crazy decimals. We'll make it a deal. All right, now this one. How how long would it take Gina to save $10,000 in a single month? Okay, so we say 10,000 equals the first one times the common ratio to the n minus 1. So we would divide by 0.25. And then how can we solve a problem such as this? We would take the log or the natural log of both sides. So we could do ln of 40,000 equals n minus 1 times ln of 2, or you could do log. They're both the same. And then the last step would be to add 1, and you're done. Okay, now Ashley is not up here, but Ashley was that arithmetic one. So it was a sub n equals 2 plus n minus 1 times 4. And so Ashley is going to be a much larger answer here. So we would subtract 2, divide by 4, and add 1. And so we get so after 16 months, Gina would get there, but it would take Ashley 2,501 months. Yeah, Ashley would take a little longer. Yeah. So Ashley may have to count on her grandchildren helping her out with that. Okay, so guys, you picked up some more practice. Okay, and you have the rest of class.